Welcome to qnawire.
Draw all geometrical isomers of this complex. Which of these isomers has an optical isomers? Draw the various optical isomers. So, uh, first we have to recall that what is geometrical isomers. We know that two types of geometrical isomers are possible, cis and trans. When same ligands are next to each other, then we can say that it is cis isomer in case of geometrical isomer. And when same ligands are arranged across from each other, then we will say it is trans isomer. And what is the meaning of optical isomers? Optical isomers should not have any kind of symmetry like plane of symmetry or center of symmetry. And one more important thing that optical isomers mirror image should be non-superimposable mirror image, and by this they can rotate the plane of polarized light. So these are optical isomers. Now we are drawing one by one all the isomers. So first we are making the cis isomer. Cis isomer, and both are actually optically active. Two cis isomers are possible and both are optically active. So we have to make their mirror images also. So first one is platinum at the center. 4 bonds are making the square planar, and this is octahedral complex. So one should be above the plane, other should be below the plane. And all are cis. That means 2Cn at cis position, 2Br at cis position, and 2 water molecules are also at cis position. So we can draw platinum, 1Cn here, second Cn here, third Cn, third can be a water molecule, OH2. OH2 should be cis, and all are at cis Br and Br. Angle is 90 degree. So this is how we can make the first structure, that is cis structure, and the second structure is also, second can be, first we are drawing the mirror image. So this is the composition. Actually this should be separated, this part, and the mirror image of this should be here, platinum at the center. 1, 2, 3, 4. One is above the plane, other one is below the plane. So Cn is here, one Cn should be here, one water molecule should be here, second water molecule is here, one Br and one Br. So this is the mirror image, and these are non-superimposable mirror images, and that is why they are optically active. These isomers are optically active. So this is one isomer, this should be the second isomer. Now in the next case, cis second isomer is also possible. One is platinum at the center. 1, 2, 3, 4, all are in the same plane. One is above the plane, other one is below the plane. So here, this isomer should have one Cn here and one Cn must be here, and here water molecule, and here it should be Br, and one Br must be here, one Br, and one water molecule must be here. So look at the position of each one. All are cis, water molecule and water molecule, 90-degree angle, and Cn is also 90-degree angle, and here one is below the plane and in the same plane Br. Here also angle is 90-degree. But this isomer is different from the first one, and its mirror image. We can draw here the mirror image. Platinum at the center. 1, 2, 3, 4 in the same plane. One is above the plane, other one is below the plane. Below the plane you should have Br. Here also one Br, and here OH2. Exactly you have to draw the mirror image. And here it should be Cn, and here water molecule, and here Cn. So these are also mirror images of each other. So this is also optically active when there is no kind of symmetry present in the molecule. So these isomers are also different. So this should be the third isomer, and this should be fourth isomer. So this is all about cis isomers. Now how many trans isomers are possible? So in case of trans isomer, you will find that there is no kind of symmetry present in the molecule, and they are not optically active. So first one is when all are trans to each other, when all groups are all Cn, Br, and water molecules are trans to each other. Trans. So we can draw platinum at the center. 1, 2, 3, 4 in the same plane. One is above the plane and other one should be below the plane. So if we are writing here Cn, trans should be Cn here, farthest from each other. And if we are writing Br here, transposition of Br is here. And if it is water molecule, transposition should be this water molecule. So there is no kind of symmetry present in the molecule, so it is not optically active. This is another isomer. Fifth isomer. Now come to the next one. Next one is when two water molecules are trans to each other. Others are cis, Cn and Br are cis, like platinum at the center, 1, 2, 3, 4, all are in the same plane. One is above the plane, other one is below the plane. So water molecules are trans to each other. So OH2 and OH2 must be here. And Cn is cis, and here also Br is cis. So this is another isomer, and this one is the sixth one. Now come to seventh. For seventh, 2Cn are trans to each other, and others are cis. So we can draw this structure also. Platinum at the center, 1, 2, 3, 4, all are in the same plane. One is above the plane, other one is below the plane. This is octahedral geometry. 2Cn trans to each other. One Cn is here, one Cn is here. And others are cis. So Br is here, Br is here, and water molecule H2O is here, and here also this is H2, cis. So this is another geometry, and this should be the seventh one. Eighth should be where two Br are trans to each other, and others are cis. So here we can draw platinum at the center, 1, 2, 3, 4, and the same plane. One is above the plane, other one is below the plane, and two Br trans to each other. So one Br is here, one Br is here, and others are cis. So Cn and Cn cis position, and water molecule should be at cis position. So this is totally different from others. This is the last one, eighth isomer, which is possible. So you can see one important thing, that if it is a trans isomer, it is having some plane of symmetry or center of symmetry, and because of that it is not optically active. Whereas in case of cis isomers, there is no kind of symmetry in the molecule, and that is why they are optically active, and their mirror images are making different isomer, and these mirror images are non-superimposable mirror images, and that is why the molecule is optically active.